Today's lesson looks at graphing quadratic functions, and we've kind of talked about this a little bit, but today we're going to make it easier. So at least at this point in the game, we're going to look at 5 critical points when graphing a quadratic function. The most important point of a parabola or a quadratic is the vertex. And in order to find the vertex, remember we have to find that axis of symmetry, which requires us to use the formula negative b over 2a. So remember, this is set up as y equals ax squared minus or plus bx plus c. And so our a happens to be 1 and our b is negative 4. So negative b, which is negative 4, or the opposite of negative 4 essentially. So those negatives will cancel, and we'll have 4 up top. And then 2 times a, and a is 1, so 2 times 1. So really what we have here is 4 over 2, or 4 divided by 2, which is 2. So my axis of symmetry is the x equals 2 line. And that axis is going to help make this a bit easier. Alright, so in order to find the vertex now, I have to plug in 2 for x into my equation. So we will do that. So y equals 2 squared minus 4 times 2 plus 3. Alright, so we just follow that. So 2 to the second is 4 minus 4 times 2, that's 8 plus 3. So 4 minus 8, I get negative 4 plus 3 is negative 1. So I know that my vertex lies on 2, negative 1. Alright, so that's the turning point of my parabola. Okay. The next thing that we'll want to do is find a point that lies to the left or the right. And I go one integer over. So for instance, if I wanted to figure out what happens when x equals 1, I'll plug 1 in and see where we land on that line. So let's plug 1 into our equation. So y equals 1 squared minus 4 times 1 plus 3. So really we have 1 minus 4 plus 3. 1 minus 4 is negative 3, and negative 3 plus 3 is 0. So 1, 0 is our next point. And the cool thing about the axis of symmetry is when there's 1 point on one side, there will be 1 point on the other side exactly the same units away from that line. So that was 1 unit to the left of the axis of symmetry. My next point is 1 unit right to the axis of symmetry. Alright, and to get our last point, which is our last 2 points, this is very easy. We're going to look for the y-intercept. So remember, way back when we did the linear equations, we had y equals mx plus b, and our y-intercept was b, because when x equaled 0, y equaled b, and that would be where it crossed the y-axis. So in this case, the y-intercept still happens when x is 0, but when x is 0, c is going to be our y-intercept. So if I did plug in 0 here, 0 to the second is 0, minus 4 times 0 is 0, plus 3 is 3. So 0, 3 is my y-intercept, and that would be mirrored across my axis, and I get a parabola. Not drawn very well, but that's how we graph them. So that's when we find those 5 critical points. However, as we will see, we won't always have 5 points. This one in particular gives us a little bit different situation. So again, we want to find our axis of symmetry, so negative b over 2a. So b is negative 6. Notice there isn't a c this time. So it would be negative 6 over 2 times a, which is 3. So we get negative 6 over 6, which is negative 1. So my axis is at negative 1. Sorry, trying to draw too fast. Weird looking line, not good. My bad. So we're going to plug negative 1 in for x, so 3 negative 1 to the second plus 6 times negative 1. And what we get here, this comes out to just positive 1, so 3 times 1 is 3. 3 plus 6 times negative 1, that's negative 6. So 3 minus 6 is negative 3. So our vertex is negative 1, negative 3. I'm going to erase my axis here. Alright, so negative 1, negative 3 is right here. And what we're going to find out now is our y-intercept also happens to be the spot where our 1 point over would be. So one integer over from the axis is also the y-intercept. So here I'm only going to be graphing 3 points, because if I went 1 unit over, that puts me right on the y-axis. Okay, so if I put 0 in for x, it becomes pretty clear that we're just going to get 0. So this happens to cross at the origin, and then since my axis of symmetry was this line, I can go 1 over, and now we have a parabola. Not a great one, and I used a lot of red, so it looks pretty funky. But that's a situation where you could put just 3 points on there. Okay. And lastly, something that looks easier but sometimes can be confusing. If you get something that looks like this, where there's no B, you're going to have the axis of symmetry right on the y-axis. Okay. And if you wanted to check that, you could say plus 0x, and you can see your b would be 0, so negative b over 2a is just going to be negative 0 over 2 times 3. And negative 0 is just 0, and 0 divided by 6 is still 0. So my axis of symmetry is 0, and if I put 0 in for x, we still get 0. So this particular parabola goes through the origin, and that's where my vertex is. So then I would just check 2 points to the left and right. So I would put in 1, 3 times 1 to the second. 1 to the second is 1, 3 times 1 is 3. So over 1 up 3, and then I would check on the other side, negative 1, and 3 times negative 1 to the second. We have to do negative 1 to the second first, which is 1, and 3 times 1 again is 3. And again, we should know that because it would just be mirrored across my axis of symmetry. So we didn't technically need to do this part, but because things are mirrored across that axis of symmetry. But anyway, when you get something that looks like this, your axis of symmetry will just be the y-axis.